Hang on. Quit it. There we go. All right. It is day 11. We are finally beginning our Algebra 2 content. So I want to give you a little sneak preview of what we're planning on talking about today. And then we're going to get into those do now questions. So first of all, I wrote these out of order for how I wanted to do them today, but I'm going to label that 1, 2, 3. So the first thing we're doing today is we are reviewing how to solve an equation because we are going to be doing a ton of that here soon, guys. Hey, guys, let's keep the talking down because the microphone's going to pick you up. Okay. So we're going to review how to solve equations like the ones that I listed in the do now. Then we're going to take those rules and we're going to learn how to do those bonus questions that we had on our quiz. We're going to be solving quadratic equations. And we're also going to review our factoring rules since we'll be using those to solve. So let's go ahead and look at our do now. I told you to solve all these equations for x. And then I also wanted you to prove that you know your x is correct. So I gave you an example of what I meant by that on the back. If I had an equation such as 2x plus 1 equals 7, here's me writing out my work to how I found x. So I had a plus 1 here, so I did the opposite and subtracted 1 from both sides, which canceled my 1's, left me with 2x equals 7 minus 1 is 6. And then I divided by 2 to get x by itself, divided 6 by 2 to keep my equation equal, and I ended up solving for x and getting a value of 3. So to prove my answer or also to check if your answer is correct, we just take that x value and replace the x in our original equation with the number we found. So to prove it, I just wrote 2 times x, or 2 times 3 plus 1 equals 7. And then I made sure that it came out to be true. 2 times 3 is 6. 6 plus 1 is 7. So I know 7 is equal to 7. So that was just the example. Okay, you guys got questions?
It kind of makes sense. Starting to come in.
Yeah, it'll make sense. We're gonna do a lot of practice. Okay, let's look at number 1 together. And we're gonna do a big overview. If you already feel comfortable solving equations, great. If not, I would highly suggest you taking some notes real quick. I'm gonna give you a mini lesson on solving equations. Okay, so here is equations mini lesson. Let's do it. So how to solve an equation. If you already know how to do this, great. If not, here's your overview of it. We should have learned how to solve an equation all the way back in pre-algebra. So this is, I'm really kind of handing you guys some help here. Normally in an Algebra 2 class, we would never go over the basic steps for this, but I want you guys to feel very secure and good about this moving forward. So if you need these steps, write them down. So let me give our number 1 for this example. I'm going to write x minus 10 equals 21. So first of all, whenever I see x in an equation, what is this called? What do we call this letter? A variable. So that is a word we're going to be saying a lot. I need you to be comfortable with knowing what variable means. So variable, it could be any letter, but usually it's going to be x. And who can explain what that means? Yeah, it's just representing a number. It's like a placeholder. Basically, what this means is what number minus 10 is the same as 21. So what number can I put here to make this true? So x is just, it's a placeholder for a number we don't know. No. Okay. So when we are solving an equation, there are some things that we need to know. This is going to sound really familiar to my Algebra 1 people I had last term. I want you to write this down. Inverse operations. As I'm finishing writing this, does anybody feel confident enough to explain to the class what inverse operations are? What does that mean? Yes, Michael.
The opposite of what the original operation is. So if it's plus, you do minus. If it's
Yeah.
times, you do division.
Perfect. So inverse operations are just doing the opposite operation. So inverse means opposite. Opposite. And when I say operations, we're always referring to the things we can do to numbers, like multiplication, division, addition, subtraction, things like that. So let's make a little chart here. I'm going to say this is addition. What is the inverse operation or the opposite of addition? Subtraction. Good. Yes, exactly, exactly. So that also means that the opposite of subtraction is addition. So these are opposites to each other. The other one that's important to keep in mind, let's look at multiplication. Yes, yes. Multiplication's inverse is division. And I'm going to abbreviate that if you guys are okay with it. Multiplication and division are opposites. Now I'm going to give you one more that we didn't talk about in Algebra 1. What about something like this? Does anybody know what the opposite of a square is? Say that one more time. So I'm not trying to solve for x here. I want to know what's the opposite of taking something to the second power?
Square root.
Who said that? Kelly, on it. Yes. Square root. So whenever you take something, a number, to the second power, this is called squaring it. So this would be read, yes, exactly, as x squared. To do the opposite of that, we do this. Oh, I should have made that in red.
Is that pi?
Pi? It's not pi.
And say, what is it called?
Square root.
Square root of? That's the
Square root of x.
Oh, so that's the actual sign for it.
Yeah, that's the sign.
Friend.
Oh, my Lord. Thank you. I get in the zone. Square. Thank you. Call me out. Square root. Okay. So we're not going to be doing too much with this just yet. I just want you to be aware that it exists. So if you are taking notes, you've got it all in one place. So those are our opposites here. We've got addition and subtraction. Those are opposites. Multiplication and division are opposites. And then squares and square roots are opposites. So whenever we are solving an equation, can I move back up to the problem? Does anybody still need this?
Yeah.
Okay. We're going back to this. I've got x minus 10 equals 21. Our goal is always to get x by itself on this side of the equation. That equal sign separates the sides. This is one side of the equation. This is the other. I want
minus 10, so plus 10 to that.
Yes.
Plus 10. You actually can do that one mental math.
You totally could do this one mentally. Absolutely. If you know that, 31 minus 10 is 21, then that's great. But let's make sure we understand the process written out. So somebody said, let's do plus 10. So can we explain why are we going to add 10?
The opposite.
We're just doing the opposite. Minus 10, we're going to add 10. Yes. So anytime we're doing something on one side of the equation, what else do I need to do? Yes. We have an equal sign here. That means these are the same. If I just do plus 10 over here and not over to the 21, then that equal sign is false. They are no longer equal. To keep them equal, we got to do the same thing on both sides. So what happens here?
10 cancel out.
Yes, negative 10 plus 10 is 0. We're not going to write x plus 0. We're just going to cross it out. Yeah, 21 plus 10 is 31. And then what do I do? Yes, we're going to bring the rest of our equation down. I still have x left, still have equals. I got 31. That is your answer. Perfect. Okay. Yes, I love it. All right, let's look at number 2. Now I have negative 4x, and I'm going to switch back to this page. Negative 4x equals 28. Yeah, so what operation is happening there?
Divide by negative 4.
Yeah, you guys are ahead of me. That's awesome. This is multiplication, so we get rid of it by dividing. Man, let me get that to focus first, though. Okay, so I am going to divide everything by negative 4. And what else do I need to do? Yes, same thing to the other side. Divide by negative 4. So what happens?
Negative 7.
So yes, 28 divided by negative 4 is negative 7.
4 cancel.
Yes, negative 4 divided by negative 4 is 1. And 1x, we don't need to write the 1. It's just x equals negative 7. And that's your answer. You circle it. Okay.
I messed up on that one.
Oh, yeah? What did you forget?
For some reason, I added 4.
Oh.
Because it was a negative, and I
Yes.
thought I had to turn it into a positive.
Yes. So I bet you're not the only one that did that. So, you see a negative and you think, oh, I'm going to add, but not always.
Because the whole inverse operations thing, it made
Yes.
me go.
And you know what? I probably should have done this. I probably should have put that in parentheses so you knew it was negative 4 times x.
So the final solution would he wrote it out to be negative 4 times negative 7.
Yes, thank you, Michael. So let's go over that next part where we're proving that we know our x is correct. So what we need to do is take that original equation, which was negative 4 times x equals 28, and we found that x was negative 7. So I want to put that in there and make sure these are equal. What's negative 4 times negative 7? Good. 28 equals 28. So we know that it's correct because they are equal to each other. This is a true statement. 28 is equal to 28. All right. Let's look at number 3. Here's where we get a little tougher. Now we're looking at a problem with more than one operation in it. So here is another part of notes that I want to remind everybody. Just like we use inverse operations, we're doing things kind of in backwards order. What do I know about order of operations whenever I'm solving an equation? I bet my Algebra 1 people might know this because I taught this a couple of times. Are you talking about like the PEMDAS? I hear parentheses coming first. Okay. So if you are like, what did she just say? PEMDAS is referring, I'm going to point my camera at it so everybody can see it real good. Let's see. PEMDAS, oh my Lord. Wonder if I can. It is that poster. This is mostly for people watching on YouTube, but you guys can look up at it right there. There. PEMDAS. Order of operations. That's the order that we normally would be solving a problem in. You know, we do things that are in parentheses first, and then we do exponents, go down the line till there's nothing left. But when we're solving an equation, it's different. What's different about it?
Do it in reverse.
Yes, you do it in reverse. Everything is in reverse when you're solving an equation. So just like we have inverse operations,
Inverse equations.
and we got inverse order of operations, or we could say like inverse PEMDAS. Inverse. I'm going to say inverse PEMDAS. So instead of writing all of those out, I'm going to give you the two most important ones that we're going to see most frequently right now. And we can always add to it later if needed. But the first thing you always want to do when looking at an equation is we want to get rid of, hello? Let's get back on here. Okay, so whenever we're solving an equation and we're doing the opposite order, the inverse order of operations, the first thing we want to do is, and I always say get rid of or cancel out. I'm going to say we want to get rid of addition and subtraction first. So get rid of addition and subtraction. That's the first step. And you're going to repeat that till there is no more addition or subtraction on that side of the equation. And the second step is to get rid of multiplication and division. So when we're solving equations, these are the two main things that we need to remember. This is basically the two laws that we're worried about for now. So I'll give everybody a second to copy that down, and then we'll go back to that problem we were working on. Go ahead and go back. Let's look at number 3. So in question number 3, I know it's kind of cut off the page. I wrote a little too close to the edge. I have 2x plus 3 equals negative 127. What do I do first?
Are you gonna minus the value out too?
Yes. Okay. So Riri just said it. We have two different things happening here. Remember, step 1, we want to get rid of the addition and subtraction first. So we want to get rid of 3 first. Minus 3 on both sides. Good.
When I plugged it in.
Okay. So, what happens next?
Three's canceled.
Yes, my 3's cancel out.
And then that number goes up.
To 130, negative 130.
Yes, negative 127 minus 3 is negative 130. And what then do I do? Yeah, let's bring everything down. I still have 2x equals negative 130.
Figure by itself, so divide that by 2, both of those.
Yes, we want our x to be by itself so that we know x is equal to something. So since I have 2 times x, we do the opposite. 2x divide by 2. Gotta do it on both sides.
Yeah, negative 65.
2's cancel. I get x equals negative 65. Perfect. Perfect, perfect.
I got that one right.
All right, can we check our answer?
Yes.
How do we check our answer?
Plug in negative 65.
Yes, we're going to plug in or replace the x in the original equation with the x that we found. So what am I going to write?
2 minus 65.
Oh, wait, 2 minus 65?
2 times.
Yes.
65.
Careful. I knew that. I'm sure that's what you meant, though. 2 times negative 65. Then what else do I need to write?
Plus 3.
Yes,
three.
plus 3 equals.
And then 127.
Good. And if we found the right x, then we should get negative 127 over here. So now we're not solving anymore. We're just using regular order of operations when we check. We only do reverse when we're solving. Now we know all the numbers. So what do I do first here?
What do you mean?
I have 2 times negative 65, and then I have something plus 3. Am I adding 3 first, or am I multiplying first? Yes, we need to multiply first. Sorry, I might not have worded that well.
Oh, you're trying to do the equation over.
Yes, we're trying to check our answer. Sorry, guys, I didn't mean to confuse you. Yes, that's going to give us negative 130. Good, plus 3 equals negative 127. And what's negative 130 plus 3? Yes. So our answer is correct. And you can do this with any equation. Plug your x back in and you will always know, like before you turn something in, you'll know if you got it right or not.
But do we have to do that part?
You do not have to do this part. I only want to kind of demonstrate this so that if you are feeling confused in the future and you're solving, you're not sure about your answer, this is how you check if it's correct, if they're equal. That's a good question, though. I'm not ever, well, I might have you do that on something, but I'll tell you if I want you to. Okay. Does anybody still need this?
You just don't want to have to solve the problem.
Yeah. Okay, are we ready for number 4?
The next 2 I was confused about.
Yes, I gave you some tricky ones here. As we go down the line, they get tougher. So I wanted to see how far we got. So for number 4, I've got 48 equals negative x plus 10. What do I need to do here?
Subtract 10 from both.
Okay, we do need to subtract 10 from both sides. So minus 10 here, minus 10 here. My
So it doesn't
10s.
matter which way the.
Yes, exactly. So these types of equations where x is on the other side of the equation tend to really throw people off. You're doing the exact same thing, it's just in a different location. So you're still trying to get x by itself. It doesn't matter whether it's on the right side or the left side of the equation. So I'm going to subtract 10. That cancels. What's 48 minus 10? Good. 38 equals negative x. Okay. Now what do I do? Because we're not done. Ooh, yeah. So remember, we're solving for x, not negative x. We can also think of, you know how if I just see x by itself, what's the invisible number right there? 1x. So if I have negative x, it's really negative 1 times x. So I don't have x by itself yet. What do I need to do to get it by itself? Yes, divide by negative 1. That's going to give us x equals negative 38. So here's another trick. If dividing by negative 1 feels like an extra step, if you get this answer, 38 equals negative x, and there's nothing else there, you can just trade places with the negative. I can just say, okay, well, if negative x is 38, then negative 38 is x. You just flip-flop them. Okay. Any questions about number 4? Yes.
Prove it.
Yes, let's prove this one. So let's prove it. I'm going to do this on a separate sheet so I have plenty of room. All right. So I'm going to just put that. There's my work. So how can I make sure my answer is right? What am I going to be writing out to the side to check?
Really plug in negative 38 into your x's.
Yeah, so I'm going to go ahead and write out my whole equation. 48 equals negative whatever x is plus 10. So I like sometimes to just put a parentheses where my x would go, and then I'm going to put my value in for x. So what do I write inside the parentheses?
38, because it's already a negative.
Oh, so here's where people might get messed up. Our x is negative 38. So I want x to go in here. This negative is part of the equation. It's not part of x. So I need to still write negative 38 like that. So when I have a negative times a negative, what's it give us? Yes, this is a positive. So I'm going to rewrite it again. 48 equals 38 plus 10. And let's make sure it's right. What's 38 plus 10?
48.
48. Correct. Yay. So we know we got the right answer. If you had gotten a positive 38 for x, then when you plug it back in, we would have 48 equals negative 38 plus 10. And that is not going to be equal. We would get, what is that answer? Negative 28. Yeah, and that doesn't work. So we would know our x was not correct and we did something wrong. So it's always a great way to check because those little mistakes make a difference. All right. Did anybody need this work still?
Yes, please.
Okay, I'll leave it up for a second.
Me and no sign.
Yes, we have to be so particular when we're solving equations and doing anything mathematical. Precision is the key here.
Yes, and me and those signs just don't get along.
And guys, I'm going to tell all of you, you guys are not alone. If I had $1 for every time I wrote, check your signs, whenever I was grading the quizzes yesterday, woo, I could retire. Oh my Lord. So we all need practice on this. If you feel like, why am I the only one not getting this? It's not just you. Everyone struggles with this. It's tough. This is a difficult subject, okay? It's just going to take practice. We'll get there. We will.
I love it. I just don't like the signs.
I know. We will get there. More and more practice.
You keep telling me that.
But Star, let's think about this. Where were you first day of first term versus today?
Let's not discuss that.
That's progress. That's progress. Okay, let's look at number 5.
What do we do back?
Yee, this one scares a lot of people. It's not as scary once we break it down. So let's talk about it. What do I do first?
Add 2 to both
Yes.
sides.
Add 2 to both sides. Yep, my -2 and +2 or +2, they cancel.
54.
Yep, then 52 plus 2 is 54.
Then
Bring down my
multiply.
equal, and then bring down, I still have x divided by 3.
But multiply.
Yes, guys, it looks scary, but it's just using our inverse operations. If I have x divided by 3, to get rid of the 3, we just multiply by 3. We got to do it to both sides. So you could do it by writing the parentheses. I'm going to say to probably get in the habit of moving towards this, where you write the parentheses, because when we get to more complex problems, it will help us not mix up the times symbol with an X, instead of writing ×3 like this. We're going to have a lot of X's in our answer. So I'm going to suggest moving forward, you use parentheses to represent multiplication. Up to you. If you can keep track of it with the X, that's fine. No big deal. But okay, so what happened here?
Cancel out.
Yeah, my 3's are going to cancel out.
3 times 54 is 162.
Did everybody get, or anyone that got this far, did you guys get 162? All right. So we have 162. Now what? Yeah, I just got to bring down my equal sign and my X. That's it. That's our answer. X is 162.
Cool.
Yeah, it is pretty cool. It's
I like that.
once you start to see kind of the pattern of what's happening as we solve these, it's pretty satisfying. I feel like it is
I
anyway.
couldn't get you number 6.
Yeah, number 6 is a challenge. Yes.
Sometimes I was looking at the board and saw that you put that as multiplication and still tried to divide it.
Which one is it?
When you got to the 54 times 3,
Oh, so you divided by 3 on accident? And I bet you're not alone. That's okay. We're learning. We're learning. It happens. Okay, guys. Do we want to prove this one? Just make sure we got it right.
please.
Said I feel like the proof is in the pudding. That's funny.
There's your that foot.
Oh my gosh.
I'm here for it.
Okay. Do we want to practice plugging this back in? Or does everybody feel good? Move on to the hard one. Okay. Okay, let's do it. Number 6. This was a challenge one because I put X's on both sides. Kind of crazy.
I'm gonna stay with.
I know. So let's talk about this. Whenever we have variables on both sides of our equation, we need to get them on the same side. Okay, so that means we need to cancel them out on one side and bring them over to the other. We just got to decide which side we want to do that to. Yes. So we can reason here. If I have a -6x or -6x, to get rid of it, I could do +6x on both sides, and then I'll have positive x's over here. If I did 28x and tried to move it here, I would have to subtract 28x, and then I would have a big negative x, and then I would have to divide by a negative again at the end, and that's just a lot of steps I don't want to try to remember. So I always say you want to bring the smaller x over. So let's add 6x to both sides. And remember, the equal sign separates the sides. So where am I going to put +6x under on this side of the equation? The 28x. These are like terms. They both have x as a variable. Okay, so 28 plus 6, 34. We agree? 34x. And where do I go from here?
You're gonna do the
Bring down the rest. I still have +3 equals -4, and these canceled out. I forgot to cross them off. Okay, now this looks a little bit easier to solve.
You do negative
So you're 3.
3 on each side.
Yes, yes. We want to get rid of addition and subtraction first, so -3 on both sides.
And this is where I got stuck, because I got 34x equals -7.
Okay, 34x equals -7. So what's happening here between the 34 and the x?
Multiplication.
Yes.
Division.
So we just divide.
Oh,
That's it. You just divide by 34. You're going to get a really crazy answer, but it's how we do it. Sometimes we get crazy answers in here. So the 34s cancel, and our x is what?
Negative 0.2.
Negative
0.2.
0.2.
okay.
Yeah, that's right.
So it's fine if it's a decimal?
Absolutely, it's fine. So we actually very soon here, probably not today, but as we get further into this new unit, we are going to get very comfortable with decimals because our answers are going to start to have a lot of them. I know we've been a lot more used to those whole numbers, but decimals are coming. They are. Okay, any questions?
Can you show the inverse operations again? I just.
Yes,
I
yes,
didn't
yes,
finish
yes.
writing them down.
Absolutely. Here, let me zoom out a little. And make this not.
Okay, so we just simplified the -7 over 34.
Yes, yes.
And ignore the rest of it, just.
Yeah.
You know.
So here,
It's
and I'll.
technically it's -0.2058.
Yes. Okay, so that's a good point to make. I'm going to turn this on. So -7 divided by 34 equals, you're going to get a long number like this. We didn't just get -0.2. Michael just decided to give me the answer to 1 decimal point. So normally, if you're going to get a decimal answer, I'll specify how many place values I want you to put your answer in. In this case, I didn't specify, so I'm happy with whatever you tell me. Okay.
And you want it as a decimal, not as state fraction.
I guess it just depends on the context. So in this case, I haven't given you any context. I don't know what I'm finding x for or like why. So I would take either answer because a fraction, this is actually a much more exact answer than -7 divided by 34. Whenever we do the division and we get that decimal and we don't include all those points, this actually, if I was going to be accurate, you don't have to know this yet, but if you're interested, to be exact, x is just approximately -0.2. This is not the exact answer, but it's what we approximated. We'll talk more about that later. Okay. Anybody still need anything that's on the screen right now? If not, we're about to get started with Unit 1. And I'm watching the time. Okay, we still got like 15 minutes. Actually, 20. Okay, can I move on?
Yes.
No, wait.
Oh. Oh my God. Okay, let me grab my note paper. Oh, you know I love you guys. So we did the do now. Let's start a fresh page of notes. And I'm going to put up a new sheet of paper. So I'm always going to suggest taking notes in here. The notes that we just took about how to solve an equation, you know, those were optional because maybe you already knew how to do it. But here we're starting a brand new unit. This will be brand new to most of us. So I'm going to highly recommend that you write this. So I'm going to start by labeling my paper as I always do. This is Algebra 2. And it's Unit 1. We're now in Unit 1. And it is day 11. So I'm going to write day 11 continued. Again, you don't have to do this, but it helps me stay on track. And this is page 2 of our notes. Because our do now was, oh, Our do now is page 1. Okay, so we are gonna make we're gonna make a guide today. I want green. And we're gonna title our guide, How to Solve a Quadratic Equation. Let's solve a quadratic equation. And what I'm going to do, let me grab one of these. I always like to give you number examples for guides that we make. So here's going to be our example problem. I'm going to say x squared plus 13x plus 36 equals 0. Okay. So remember that a quadratic equation, in this case, we are in a standard form here. That's the ax squared plus bx plus c equals 0. And I'm not asking you to be able to recognize this is called standard form just yet. If you want to have it in your notes, this is it. But I'm just telling you, if you're curious, this is standard form. So when we are trying to solve a quadratic equation, we can see here that we've got some weird things going on. I've got x squared and I've got an x. So the first thing we're going to do, here's our step 1. Is we're actually going to factor the quadratic first. That's step 1. Factor the quadratic. And what I mean by factor the quadratic is I'm talking about this part here that it's in parentheses. My x squared plus 13x plus 36. This is exactly what we just quizzed over. So it should be very fresh in our minds. So what's the first thing I should probably do here to factor? We are going to be finding our factors of 36. Now this is something you might be doing in your head, but I also always want us to think about what's our A, B, and C.
Oh, okay, sorry.
Oh, you're good. You were correct.
So it'll be 1, 13, and 36?
Yes, 1, 13, and 36. We need to be really good at knowing what our A, B, and C are, because those are going to really come in handy later on. So just like you said, Mac, we are going to be finding the factors of 36 or the factors of C. And remember, when we factor a quadratic, what's our answer format going to look like? What's going to be in our, yeah, go ahead.
Parentheses x, parentheses, parentheses x.
Yes. So I'm going to have x plus something times x plus something. And since I have all positive numbers, I could go ahead and put pluses in, But if you don't feel super confident yet to do that and you would rather check your factors first and then see, that's also just fine. So 36, let's check our factors. What's our possibilities here?
36.
1 and 36.
36 and 1.
Yep. 2 and what?
18.
18. Can I do 3?
Yes.
3 and what?
Times 12.
12. 4 and 9. Oh, yeah, let's stop. What's 4 plus 9?
13.
13. That's our B. Okay. So, what am I going to do with those?
Plug them in.
Yes, I'm going to put them in my answer. X plus 4, X plus 9. So, here is my factored quadratic. So now, what I've done is I have essentially, let me think of the best way to explain it. So just like, where did the do now go? Just like in our example we did in the do now for any of these problems, I'll talk about maybe this one, number 3. Whenever I got to 2 times x, and I divided by 2, I was using my inverse operations. I did the opposite thing here. And basically what happened is I separated it into my factors. 2 times x here gives us those 2x. We just kind of reversed this into what I need to multiply together to get that original quadratic equation. I think I'm being really wordy. That might have gone over a bunch of your heads, and that's my fault. Basically, we remember that factoring means finding the 2 things that multiply by each other to get the original answer, right? So we just found the things that we need to multiply together, okay? To get this, x squared plus 13x plus 36. Now, instead of this just being our answer, we have another step to do because we didn't have just a quadratic expression. Now it's equal to 0, so we have an equation. When there's an equal sign, that's what makes it an equation. So we're going to set both of these equal to 0 so that we don't have to mess with the x squared anymore. So step 2, set the factors equal to 0, or that 0 there. So let's do that. That means my first factor was x plus 4. So I'm going to write x plus 4 equals 0. And my second one was x plus 9. X plus 9 equals 0. So for the next part in the second step is once you set them equal to 0, you're just going to solve both equations that we made. Yeah. Step 2 is kind of here, I'll make bullet points. Set the factors equal to 0 and then solve both equations. So I'll give you guys a minute to write all that. And then once we're ready, somebody tell me what we're going to do in that first equation.
-4.
Yes. We got plus 4. We're doing the inverse operations here. Minus 4 on both sides. Yep, and then those are going to cancel out. Yeah, and then x equals what?
-4.
-4. Simple as that. That's our answer. Now, we're done with this one, but we do also need to solve this one as well. So, same process. 9 here, -9 here. My +9 and -9 cancel.
Down the end.
Yep. Bring down the x, bring down the equal. 0 minus 9 is -9.
So pretty much whatever the answer is like you can just easily just figure it out because it'll always be within the equation.
Pretty much. Anytime you're having factors where it's just x plus a number or x minus a number, your x is going to be equal to the opposite of whatever was in your parentheses. So I had x plus 4. My answer's x is a -4. And x plus 9, my answer was x equals -9. So these are our answers. We have 2 values for x. Whenever we're solving quadratic equations, we're going to get 2 answers for x. Okay. Questions about this? Okay, guys. Let's run through maybe 1 or 2 more together. And then after lunch, we're going to definitely do some practice with this and make sure that I can come around, check on everyone, give you some one-on-one help. But I think we've got time for 1 more before lunch, so let's do 1 more. Oop, losing everything. Okay, let me grab my, well, now where'd that go? I just brought a worksheet up here, and now it's disappeared. I literally just had it sitting on my desk. Hang on. Set it to the side. Okay. Let's do another example together. I'm going to get a separate sheet of paper as well. I'll use this. Anybody still need this guide? Can I move it? Okay, I'm going to move it. Let's try. How about 2x squared minus 32x plus 126. Okay, what do we check for first when we factor? Yes, is there a GCF?
Yes.
There is. What is it?
2.
2. Oh, and I forgot to say this is equal to 0.
Say equals 0.
Yes. Okay, so the GCF is 2. So let's divide it all by 2. I'm going to put that 2 on the outside. And what are we left with?
1 minute.
X squared minus what?
16.
Good. 16x. I saw a lot of you on your quiz forget to write the x on your middle term. Make sure you're writing it. Plus what? 63 equals 0. Okay.
Is that the answer?
No.
Have we solved for x?
No.
Nope. So let's go further. That's okay.
I gotta do the factor of 63.
We now have a is 1, b is -16, c is 63. Let's do that, Mac. Factors of 63. What can we do here?
3.
Got 1 and 63.
Sorry.
Can't do 2. Can we do 3?
3 times 21.
3 and 21.
7 times 9.
7 and 9.
That's it.
Okay. And what's our b again?
16. -16.
-16. So what sign do our factors need to have?
Negative.
Both of them have to be negative.
It'll be -7, -9.
Ah, yes. -7 minus 9 or plus -9 is -16. So, what's our answer?
X minus 7.
Good.
X minus 9.
x minus 9. Okay,
So
now we are about to have lunch in like 2 minutes. I want you guys to come up with your prediction for the values of x before lunch.
X equals 7, X equals
I'll tell you when we get back if you're right. I bet you're right. Okay. Uh-huh. Okay, gonna pause this recording. You guys enjoy your lunch. Come back at 12:35 and we'll talk a little more about this. Okay, back from lunch. So here's what we need to do. So whenever we did the previous problem, let me see it. Where is that previous problem we did? Just like this. Once we had our parentheses here, our factors by themselves with nothing else, we could just set them both equal to 0 and solve. Now, in this case, we do have these, but we also have both of our factors times 2. So we do need to get rid of that first. So times 2, let's remember their inverse operations we talked about. What's the opposite of multiplication? Division. So if I just divide this side of my equation by 2 and my other side by 2, and Mac, your answer's still correct. Because watch what happens. My 2's are going to cancel, which leaves me with just x minus 7 times x minus 9. Drop down my equal. What's 0 divided by 2? It's still 0. Okay. So now we have those factors by themselves. So we can set both of these equal to 0. And because there's no other numbers involved, just like we said last time, here, I'm going to put this here. Whatever the sign is when it's in parentheses, the opposite sign will be our answer. So let's do the work together. Set them both equal to 0. How do I solve x minus 7 equals 0?
plus 7.
Yeah, we're going to add 7 to both sides. Good. 7's cancel, and I get x equals 7. And the exact same thing happens with x minus 9. Just add 9 to both sides, and we get x equals 9. So these would be our answers. Now, you might be asking yourself, what was the point of dividing by 2? Couldn't we have just ignored it and set it equal to 0?
Yeah.
So in this case, just because there is a 0 on the other side of the equal sign, we could reason that if I do anything like times 0 or divided by 0, it's going to stay 0. So we could have kind of done this part in our head, but there will be problems in the future where it is not equal to 0. And in those cases, that step is going to be very important, because instead of setting x minus 7 equal to 0, it'll be x minus 7 is equal to some number you're given. Okay, and then it'll be the same process, but it'll be a different answer. Yes.
So what I did was I just kept the 2.
Uh-huh.
So then I had 2 and then x minus 7 equals 0, and then on the other side I had 2 and x minus 9 equals 0. And I brought the 2 with me, and then divided by 2 at the end. Still.
Say that one more time. Can you walk me through that? Or maybe show your work. Can I put your work up here so everybody can see what you're talking about? That's okay. Okay, so here's Kelly's work. Kelly, explain what you did.
So I just took the 2 and I kept it with the minus 9 and the minus 7.
Oh.
Because it would go into both sides anyway. So
I see. So it looks like what Kelly did. Can I write on this? Yeah. So Kelly kept the 2 on both of the factors. And instead of dividing and then setting to 0, looks like she distributed on both of these first to get 2x minus 14 equals 0. And she added 14 to get rid of it. I'll cross that. So she brought down her 2x equal to, and this was an invisible step, but she added 14 here to get 14. And then she divided by 2 and got 7. And she got the right answer that time too. And same as over here. That's really cool. So you did the same step. You ended up dividing by 2. You just did it kind of in a slightly different order. That's actually really cool. I've never thought of doing it that way. I like that. So this would work too. Absolutely. Whichever makes more sense to you. Yes.
So what she did is she just proved that we're already correct because she did the extra step.
Yes. Pretty much.
Now that makes more sense to me.
Well, great. If this makes, and thank you for sharing then, Kelly. If this makes more sense to you, do it this way.
That makes more sense.
I know. There's a lot of different ways to get the same correct answer. Thank you.
I'm gonna do it that way, just so I can have what two ways to-
Yeah. Well, here, let's try another one like this.
That's great.
Let's try another one like this.
Nah.
Yeah.
Okay. How about we try... I want us to solve 2. Actually, I don't want to do a 2. Sorry. I want to make it a little different. Let's do 3x squared minus 12x and 3x squared minus 12x and minus 36. Okay. And that is equal to 0 in this case. So,
Three.
yes, there is a greatest common factor. It's 3. We could go ahead and factor that out.
Then you get 3 divided by each number?
Mm-hmm. So if I divide everything by 3,
That's 1.
I'm going to put it on the outside and divide everything. That's correct. This is going to be just x squared minus what?
4.
Good. 4x. Good. Minus 12 is equal to 0. Okay. Where do I go from here?
Rid of 3.
Get rid of the 3?
Yes,
You want to just do that now?
Yeah.
Sure.
Might as well
Wait,
get it out of the way.
Where we going? Wait.
So, we have an equation here. As long as I do the same thing to both sides, it's going to work. As long as I do the same thing to both sides, it's going to stay equal. It's going to be a true equation. So what if we just divided by 3 first and got rid of it? It would work. It would work. Let's just get rid of it. Now, we could have just done that in the first step. We could have just got rid of it.
Well, why didn't we?
I don't know. Well, because we just factored out the greatest common factor, so we kept it.
You confused me all over.
Uh-oh.
Yeah, I don't want that to do that way anymore.
Okay, so
Jesus Christ, that was crazy.
Okay, if it's 0 here and we're getting rid of it,
I'm
why not just
confusing
do it
myself.
the
I thought we
first
find the
step
greatest
and be done?
common factor, and then we find the factors for C.
yes, so all that was happening here, so Star just suggested that maybe we just divide by 3 so that our answer doesn't look like 3x and x. Our answer would just look like this. The 3 would just already be gone.
Oh.
So she's just dividing now so we don't have to worry about it later.
So you can do it in any order?
Yeah, you really could.
Okay, go
In
ahead.
this
What?
case.
Yeah, now I'm
Because
flabbergasted.
all we're solving for is what's in those parentheses, right?
Yes. We're
So
solving
it
for the
is
values
fine
of
to
x.
Get rid of all that stuff on the outside.
Yes, exactly. We're kind of just simplifying.
Yeah.
Okay. So, either way, whatever makes you feel better. Whenever we're getting down to this point and we're factoring the outside numbers, if our equation is equal to 0, you can kind of just neglect them and pretend that they don't exist. In the future, when we do have a number bigger than 0 or smaller than 0, we'll have to pay more attention. So I guess it's good to stay in the habit of keeping track of those. We're just doing it in a different order right now. So let's worry about the factors first. How about that? We'll come back to Star's suggestion. I don't want to confuse everybody.
I'm about to say, is that the answer?
We're solving for x, so we don't know what x is yet. We got to find x still. So we have our GCF factored out here. How am I going to factor the expression inside the parentheses? Yes, factors of -12. What are those? 1 and 12, or -12, yep. 2, -6. We can stop there. Why can we stop there?
-6, -4.
Yes, because our b is -4, and 2 minus 6 is -4. So what do I do with these numbers?
Plug them into your equation.
Yeah, plus 2 minus 6 equals 0. Okay, now what Star was suggesting we do, we could do that. Divide by 3 on both sides just to get rid of that 3. And I cross that out because 0 divided by anything, it's going to stay 0. Now I've got x plus 2 times x minus 6 is equal to 0.
Okay. Yeah, because when you were doing it before, it definitely threw me off.
Yes, I'm sorry. I don't mean to throw you guys off. I know, this is new stuff. We should be waiting until we add extra steps like that. Let's try to just stay by the book until we're all comfortable. So what do I do from here now? Yeah, I'm going to pull these out, set them both to 0, and solve for both of my x's. I have x plus 2 equals 0, and x minus 6 equals 0.
-2.
Yeah.
-2, x equals
X
-2.
is -2.
X equals 6.
Yeah. And since it was -6, we added 6 to both sides. And I will get x equals 6. So these are my values of x in this case. Now let me pull something up. Hang on, sorry guys. I found a really cool website that I'm gonna definitely play around with a little more before I have you guys try this. But I found, you guys continue copying. Let me look for something. Okay. Sorry, I'm kind of thinking out loud right now. Any questions about this one? Okay, so in the last few examples we've been doing, we have been looking at quadratic equations where our a can either start as 1 or where a becomes 1 after we factor out the GCF. But what if we have something where either there is no GCF and a is greater than 1? So let me give you an example. Okay, focus. There we go. Let's try 2x squared minus 3x minus 2 equals 0. Okay. So
That it doesn't have a GC.
Well, let's look. Is there a GCF? How can we tell?
No. So you just write your T down to your parentheses.
Yeah, so remember, whenever we're trying to find a GCF, we're looking to see if there's any number that we can divide each of the terms by evenly, and there is not. There is not. So our A is greater than 1, it's 2. B is -3. C is -2. Mac, you're exactly right. Whenever we're not able to get our A reduced to 1, A needs to be in our answer, just like the problems on our quiz. So I have 2x here and x equals 0. So remind me, how am I going to find those factors?
Factors of -2.
Ah, be careful with signs. Factors of -2. And when we are factoring a negative number, what signs will my factors have? Opposite signs, one positive, one negative. So let's start.
-2, 2 and -1.
Yep, 1 times -2, 2 times, 2 times -1. These are our only two options. So now we need to think about whenever we plug these in.
Do the rainbow method. -2.
Yes. Now, whenever we do that rainbow method, which value or term are we checking with?
The outer term and then the inner term.
Yes, you're going to be doing this whole process. But how are we going to know that we have the right numbers?
What equal it to be?
Yes, we need to end up having -3x when we multiply and add them together. So, which one do you guys want to try first?
2 and -1.
2 and -1?
2 times -2.
Okay, so 1 and -2. Let's try that. Okay, so what is 1 times x? 1x. 2x times -2?
4.
-4x. And what do you know? 1x minus, yep, -3x. So, we got it. Those are the correct factors. So, we got to this point. Give everybody a moment to make sure they've got it all written down and they're all caught up. I want you to think about this. What do you think we're going to do now to solve for x? Yes, exact same thing. I'm just going to make 2 separate equations, set them equal to 0. So I've got 2x plus 1 equals 0. And I've got x minus 2 equals 0. So what should I do on my first equation?
-1.
Yes, subtract 1 from both sides first. And what happens here?
2x equals 0. Then you
Good.
have to divide.
2x equals what?
-1.
-1. 0 minus 1.
Oh,
-1. That's all right. Okay. So we're here. Then what? Yeah. Divide by 2 to get x by itself. We want those 2's to cancel. So what is our answer?
X equals 0.
Yes, so we have 2 answers that I would accept here. They're the same answer, just written differently. We could either keep it as a fraction and just say x is -1/2, or we could divide -1 by 2 and get -0.5. Both answers are correct. Yes. Go ahead. You're fine. You're totally fine. Okay, so we have one of our answers. You keep it. How about our next one? Yeah, just add 2 to both sides. I get x equals 2. There you go. So whenever we have a quadratic equation, it's really not as tough as it may look. You're just finding the factors, setting them both to 0, and then you use your inverse operations to solve for x. And we'll always get 2 values for x unless we have the same numbers in our parentheses. Then we'll end up getting the same answer on both of them.
Still kind of ran a little bit.
Yeah,
I'm
yeah,
still
you
kind
know,
of confused about
I
it.
understand. You know, this is a little new for us, and you guys are doing a really great job with it. For this being the first day we really look at it, you guys are doing wonderful.
See you tomorrow.
See, yeah. So what I am going to do is I'm going to give you just a couple of problems to try on your own. I'm going to set a little timer, and I would like to see how we do with those without me guiding you through it. So let me.
Is this our exit ticket?
No,
Dang it.
we've only been in here for a little bit. I know, Algebra 1, we would finish like usually first half of class, but Algebra 2, there's a lot more stuff to cover, so it's a
That's
little,
okay.
little more involved.
I love math.
Oh,
Math just doesn't like
good.
me.
I'm glad. Okay.
Jeremiah got it.
Okay, I'm going to give you just a couple here. I would like for you guys to start with number 1. Solve x squared minus 5x plus 6 equals 0. I think I'm just going to give you like 4 for now. And just a few minutes to practice.
You put 4.
Yeah, you call it.
Oh, my bad. My bad. Sorry, guys. I'll fix it.
4. Seriously.
I'll fix it. 3. Okay, let's see.
Damn you guys.
Yeah, Star, you would never correct me. Okay, 3x squared minus x minus 0. And then
Another question?
actually, let's just stick with those 3 for now. And then we'll come together in a few minutes. I'm going to set like a 10-minute timer. I want you guys to just get as far as you can on those. I'm going to come around, see how we're doing.
Are we just doing the same thing we've been doing?
Exactly,
Okay.
yes. And I will come back after this. Okay, so I'm going to try to fit my work on one page this time. Let's look at the first problem. I have, I'll label it for you, x squared minus 5x plus 6 equals 0. What do we do here first?
Identify A, B, and C.
Yeah, what's our A, B, and C here?
1, -5, and 6.
Yeah, we've got A is 1, B is -5, C is 6. Our A is 1, so we don't need to check for greatest common factor here, do we?
No.
No. So how are we going to go from here?
Find factors of 6 and write your equation.
Yeah, I'm going to go ahead and write what my format for my factored form is going to look like. And now we'll do exactly that. Let's find our factors of 6. Now, what are the factors of a positive number? What signs will they have? You could either have two positive numbers or two negative numbers, either one. So factors of 6, we've got 1 and 6, 2 and 3, and we're going to stop there because we don't need to check the flip-flop since our A is 1. We can interchange them. Okay, what should I try?
200.
Okay, so 2 plus 3 is 5. What's our B? Negative 5. So it's not going to be positive 2 and positive 3. Yeah, all we got to do is, and I've told a couple of you this while I was walking around, a good rule of thumb is if you are getting the correct number, but the incorrect sign, usually you can just switch the signs and see if it gives you the right answer. So let's try negative 2 and negative 3. And that's going to give me negative 5. So I'm going to put x minus 2.
So both of those can be minuses?
Yes, because two negatives, when you multiply them together, they make a positive. So these are still factors of positive 6.
Okay, so.
All right. Any other questions before we continue this one? All right. How do we solve for x now? Yeah, we're going to separate these into two equations. X minus 2 equals 0, and x minus 3 equals 0. So inverse operations, if I'm subtracting 2 here, I'm going to add 2 both sides. And those cancel. So what's the answer to my first equation? X equals 2. Good. And same process on the second one. Add 3. X equals 3. Okay, yes.
I did it with 1 and negative 6.
Yeah, I did too.
Oh,
That's what I
one.
did.
Okay, but let's think about it.
Oh,
1 times negative 6 is going to give us negative 6. And our C is a positive 6. So your factors have to match your C. They can't, so we can't just, is that the one that I told you to switch signs on? Okay, good. I was making sure I didn't tell you wrong.
Nice.
So we have to make sure, first of all, that the numbers we're choosing are still factors of C. So if I tried 1 and 6 and I think, oh, well, that's going to make 7. But if I do minus 6 and positive 1, that will give me negative 5x, but it's going to give me minus 6. And I need it to stay plus 6. Yes.
so like, I tried slightly messed up on the side signs again.
Mhm.
So it's not necessarily negative 3, it's just minus 3. It's still a positive though.
You mean here?
Yeah,
Yes.
okay.
Yes.
I'll remember.
Okay. So that's our answer. Any other questions?
No, I didn't write it down.
Okay, you're fine. I'll keep it up here for a minute.
Gosh darn it.
I thought I had it.
Who got it right?
Ew.
Okay, you got it right? Anybody else? Who got it right? Raise your hand. I want to see who got it right.
Of course, Jeremiah did.
Okay, that's a pretty good number of us. That's awesome. Awesome. Okay.
No, I'd be shocked if Jeremiah got it wrong.
I
Oh,
make mistakes all the time.
Sure, you did.
fuck you guys. Okay, I'm going to go ahead and write down number 2, just so I have
I'll do
it.
that tomorrow.
Okay. Slowly shifting. Are we all done writing? Do we still need it? You still need it, or yes, please, you're done?
You have your, I'll get it off of her. Go for it.
Are you sure? Okay. All right, number 2. What's going on in number 2?
Identify your A, B, and C.
Yeah, let's talk about our A, B, and C. What's our A?
2 x squared.
2.
Oh, x squared.
1, -1, -3.
Yeah, B is -1. C is -3. So
-3.
if my A is greater than 1, what's the first thing that we like to check for? A greatest common factor. Does this have a greatest common factor? No, it does not. So what does that mean about A?
Bring your A down.
Yes. A is going to be part of our factors. So we're going to have 2x and x equals 0. Okay. So how are we going to decide what goes in those parentheses again?
Find factors for -3.
Yes, factors of -3 or of C. And what are all the possible factors?
1 and 3, 3 and 1.
1 and -3.
3 and -3 and -1.
Yeah, 3 and -1, and that's it. These are our only options.
-3.
So what do we want to try, guys?
-3.
So -3 plus 1?
Yeah.
Okay, let's try it. So how do we check again?
Outer term and inner term.
Yeah, we're going to do that rainbow. 2x times 1 is 2x. -3 times x.
-3 equals -1.
Yep, so 2x minus 3x equals -x. And that is our middle term. So that's good. So now what do we do?
Right. Separate the and make it the.
Yes, let's separate our factors into 2 separate equations and set them to 0. So we'll start with 2x minus 3 equals 0, and then x plus 1 equals 0. All right, let's do the 2x minus 3 first.
Go out the 3 by adding.
Yes, we want to get rid of addition and subtraction first. So since I've got -3, we're going to add 3 to both sides. My 3's will cancel. And that leaves me with
Then you division.
2x equals 3. So to get rid of the 2, we divide. Okay, so that's going to give us x equals 3 divided by 2. 1.5 or 1.5. Wonderful. Okay, any questions about this part? Awesome. Let's try the other one. I think we got this one. -1. X is -1. So there's our answers. X equals 1.5 and x equals -1.
See, I got it all right, except for when I did x minus 3 because I forgot the 2 and I got a completely different answer.
Oh, okay, I get you. I get you. So what answer did you get?
I erased it, so I don't even.
Oh, that's all right. All right. Does anybody want to share maybe if they got a wrong answer and what they did? Because I bet you're not the only one that made a mistake. Might be nice to see what many of us might be mixing up. Or did we all get it right?
I just forgot.
Gabby, yeah.
Yeah, I had the numbers mixed up and I didn't have the numbers mixed up, but I had the signs mixed up.
Okay, so did you have +3 and -1? Yeah, I bet a bunch of you did that. Did any of you get stuck trying to figure out which numbers to put in your parentheses? Because you kept getting +1 with the rainbow? I saw a few people when I was walking around had 2x plus 3 and 2x minus 1, and they were a little stuck there. So again, I'll repeat that as a rule of thumb. If you have tried factors and you do that rainbow method and you get the correct number, but the incorrect sign, try flip-flopping your signs and see if it fixes your answer. It usually will. So if I had like plus 3 and minus 1, it would have given me positive x. Since I wanted it to be negative x, I just switched them to a minus and a plus here instead. Okay, do we have questions about the second problem here? Or do we want to look at the third one? Okay, I'm gonna move it. Let's go all the way back up here. Number 3, actually I'm gonna go here. And okay, number 3. I've got 3x squared minus x minus 10 equals 0. What's going on here?
Let's letter them. A, B, and C.
Mm-hmm. We got A is what?
3
3.
is -1.
Good. -1.
C is -10.
-10. Perfect.
Now
And-
you bring your 3 down here. Quick.
Yeah, we're going to have to bring A, or that 3, into our factors because there's no greatest common factor here. We can't divide anything. So I'm going to have 3x. X equals 0.
Find the factors of negative.
Yes, factors of -10. And what are those? Yeah, we could have 2,
-2 and 5.
-5. We could do -2 and 5. Is there any in particular that we want to try?
Fine.
-2 and 5? Okay, I heard people yell that one out. Let's try that. -2 plus 5. -2 times x gives me -2x. Okay, 3x times 5 is 15x. So that's going to give me too big. So that's not right.
I did,
Fine.
yeah.
Flip the numbers
And fine.
and signs. So 3x plus 5.
Yeah.
Okay, let's try that. 3x plus 5 and x minus 2.
I got 3x times -2. And then
You got, what, say that again?
I'm going to do my rainbow method. I got 3x times -2 and
Yeah. 3x times -2 and then 5 times x. So that's 5x and -6x. Oh, look at that.
-1.
We get -x. That matches.
Yeah, can you pull it up?
Oh, sorry guys. I didn't even realize I was going off the screen. My bad. Thank you for saying something. I get in the zone sometimes. Okay. Where do we go from here?
Your factors are correct, so you separate your factors into a
Yeah.
3x plus 5 equals 0. And x minus 2 equals 0.
3x plus 5 equals 0, and x minus 2 equals 0. Okay, so let's solve the first one.
Fraction on the first.
Yes.
Minus 5.
Minus 5
3x down divided by 3.
equals -5, and then you're exactly right. We'll divide by 3 on both sides.
So,
Good. Yep, -5 divided by 3. Say that again, Michael.
-1.7.
-1 point, did you round it?
It's 1.66.
Oh, okay, -1.66 or 1.7.
Need the fraction.
We could also leave it as a fraction for now. But whenever we get to graphing, we'll want to make it a decimal. So I'll explain a little more once we get there.
It can be -1.7, right?
I got -1.
Say that one more time.
It can be -1.7, right?
So whenever I'm not telling you specifically how many decimal places I want you to put it as, 1.7 or -1.7 would be a totally acceptable answer. Yes. I usually put 2 decimal places just so I have it a teeny bit more accurate, but unless I tell you to do it differently, that would be fine. Okay, I'm on to the next one. X minus 2 equals 0. We add 2 to both sides and we get x equals 2. And that's our answers.
I once
Okay.
again forgot to drop down the 3 on the thing, and I messed up again.
For your factors here.
Yeah.
Okay, I getcha.
Yeah.
Yep,
So I
so
did get x equals negative 1.66. I don't remember what I got because I erased it. again,
Right.
But I got a complete different number.
okay, I get you. And you know, that is definitely where we might get a little mixed up is, you know, whenever we forget some of those rules when we're factoring, like if your A is bigger than 1 and we can't get rid of it by the GCF, then it does have to be in our answer. But you know, repetition makes us perfect. We'll get better. We'll get better and better as we go. All right. We feel okay on these ish?
Yeah. Somewhat.
Better than we did when we first came in here?
Yeah.
That's good. Progress. Okay. Let me think. It is 1:37. We still have like 20 minutes.
134.
Yeah, 1/3.
Oh, I forgot. I set my watch 3 minutes ahead because I'm always late.
That makes so much sense.
No.
So like I have to. It's terrible. All right, I'm gonna move this out. You think you guys can handle being introduced to one more thing?
Oh no.
Just one.
Let's do it.
Let's do it. Come on.
But
Let's try. Let's try. Let's try.
Sorry.
Okay.
My brain.
So, what if we have one of those quadratics that's not factorable? Because those exist. What if we had one of those that's not factorable? You just said it. Well, this is what we would do. We would use a different method of solving, and I have a problem that'll work for this. I just gotta pull it out. Okay. So let's say I gave you, I'm gonna zoom in a bunch because I'm gonna try to write a little smaller. Okay, and this would be page 7 for me. I'm kind of talking to myself. Okay, so what if I gave you x squared plus 6x plus 4 equals 0? We could try to factor this. We could try. And, you know, hypothetically, or I guess not even hypothetically, this is what would actually happen. If I found my factors of 4, I know that those are 1 and 4, 2 and 2. 1 plus 4 is 5. 2 plus 2 is 4. Neither of those are equal to my b term, 6. So this is not factorable. So when we have an equation that includes a non-factorable quadratic, an unfactorable quadratic, this is a case where this formula really comes in handy. I'm going to give you a word. Quadratic formula. So I'm going to color code this so you know what we're really doing here. Here is the formula. X equals. Here we go. Yes. So here is the quadratic formula. X equals negative b and then plus or minus. I'll explain what that means. The square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. Okay, so the green are the values that we plug into the formula. Everything that I wrote in black does not change. Only the green parts change. So, in this equation, what are our values for A, B, and C? 1, 6, and 4. I'm going to make a little key for myself. A equals 1. B equals 6. And C equals 4. Okay. So let's practice using this formula. Let's plug everything in. If I know that those are my values, hang on, my poor black markers are just drying out. I use them too much.
So the black never changes?
Yes, this is not going to change. The only thing that you are putting into this formula is A, B, and C.
Jeremiah, isn't this what you just taught me?
Yes. Oh, so you know this?
Yes.
Look at you.
Jeremiah just taught me it.
Okay.
What the heck?
So let's see.
Outside of class. And Michael. What? And Michael.
Everybody has questions. I'm always happy to answer.
Yeah.
Okay, guys, what am I going to write? I'm going to start with the top half. Yeah, so I need to write negative 6 plus or minus the square root of, yep, 6 squared minus 4 times A is 1, C is 4. Okay, and then all of it gets divided by 2 times A, and in this case our A is just 1. So here's where the order of operations really matters, because we have a lot of operations happening right now. A lot of operations. So let's be very careful as we go through this. So our order of operations, remember, we've got parentheses, exponents, multiplication, I don't know what I'm doing here, guys, division, addition, subtraction. Kind of just giving the best key I can. It's up on the wall too. So what's the first thing that we should do?
The parentheses 1 and 4.
So parentheses is also referring to just grouping symbols in general. And whenever I have parentheses around just one number by itself, that's usually to represent that we're multiplying. Whenever we refer to parentheses in the order of operations, we're referring more to like if there is an operation inside the parentheses. So
We have to look at our exponents for 6 squared.
yeah, 6 squared. Let's do that. What's 6 times 6? Good. 36. So as I do each part of this, I'm going to cross it off so I know I'm done with it. And I'm going to write 36 down here. And then I'm going to rewrite things. Now, you can combine steps and do a couple things at once sometimes, but I'm going to do it really slowly, one at a time, since this is our first time doing this. I'm rewriting everything. I don't expect you to do this, but I am. Okay, we got 6 squared. What do I need to do next? Yeah. Yeah, we have 4 times 1 times 4. What's that going to give us? 16. So I'm going to cross those off. And I'm going to bring it down. Or, you know what I could do? I'm going to write 16 right here. What's 36 minus 16? 20. Okay. So, I'm going to rewrite it all. -6 plus or minus the square root of 20 all over, yes, exactly, 2 times 1 is 2. Okay.
Yeah, you lost me. This is where you lost me. I got lost.
Yeah, I was with you until you wrote that thing.
Okay, so here is what happens next.
I was lost at 20.
This is where we bust out the fancy calculators. So, real quick, guys, I'm going to demonstrate this with one of these calculators, and we're going to start using these very soon. Probably tomorrow. Probably tomorrow. The only reason I'm not having us use them today is because we don't have all the batteries right now, and I got to get them all figured out before tomorrow. So, here's where we can type in more complex things. So watch this. I'm going to work on the top part of my fraction. First of all, whenever it says 6 plus or minus the square root of 20, all this means is that we have 2 separate things here. When we are solving a quadratic equation, we always get 2 answers for x, right? This is where the 2 answers are coming from in this equation. We're separating it to -6 plus square root of 20 divided by 2 and -6 minus square root of 20 divided by 2. Okay? So I just separated them. Now, watch what I can do. On this calculator, I can type, let's get rid of that glare, -6 plus the square root of 20. And I get a number.
How'd you get the square roots out?
So we will learn how to do this in detail, but you can actually do this on these calculators too.
Yeah.
So watch this. Watch this. -6. There's my -6. Oh, it's off. Hang on. All right. All right. -6. Oh no. Sorry, guys. -6 plus. Okay. Here's how you make a square root on this calculator. You guys see this little symbol next to the 7 that says x squared? Right above that button, there's a light blue square root. To use the light blue symbols, we hit the button at the top left-hand corner that says second. So I'll click that, and then I click x squared with that thing up there. There's the square root, and then I just type 20. And look at that. Enter. I got ding, 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 the same answer. Yeah. Okay, so while we still have this whole long decimal in our calculator, we still need to divide by 2, remember? So just divide by 2. So your answer, I'm going to have you go to 2 decimal places. Your first value of x equals 0.76. That's one of your x's. See if you guys can get the second one by yourself.
I didn't put a 0.
That's okay if you don't put 0. That is just kind of to make the decimal point more clear so nobody thinks it's negative 76. Okay, and then see if you can get the second one, the bottom one, by yourself. I bet you can. What are you hun about over there?
I was just thinking about how you got that square root. I didn't know the second function did that on here.
Yeah! I just figured that out the other day. I didn't realize these little calculators could do that.
Yeah, I didn't either.
It's
So
pretty
I did it
nifty.
different way.
Oh, how did you do it?
So I put the exponent, I actually did just the little up arrow right and
Yeah.
put it to a 1/2 power.
Oh, so you did, that takes a lot of math knowledge to know to do that. So good for you. That's awesome. We're probably going to hold off on that as a class, but if you can do that, excellent. I love it.
It's a lot easier like you showed it.
I'm sure you're not alone. Okay, guys, what answers are you getting?
I got what, 13?
I got negative 5.23.
I got negative 5.232.
4. Yeah.
Okay, so there's a way that you might end up getting a different answer than the one I wanted. Negative 5.23. If we rounded, it would be 0.24, but I'm just going to put 23 because we're not to that. So whenever you do negative 6 minus the square root of 20, you have to hit enter first. If you just write in your calculator, I'll show you what happens. Negative 6 minus square root of 20. If I just do divided by 2 right away, what my calculator is reading this as is the square root of 10, because we've got 20 divided by 2 all in the square root. So you need to hit enter first, then divide by 2. So actually, let me see what answer we would have gotten, and maybe your answer will be this one. So negative 6 minus, let me think. Oh my Lord.
We'll have enough time for exit ticket.
I know. Okay.
Oh, darn it.
20.
I'm so sad about this information.
Okay, yeah, see, this is how you would have gotten, if you got negative 9.16, it is because you did not divide by 2 after getting your answer.
I need a little bit more practice with this.
Yes, so I just wanted to introduce this today.
I appreciate that.
I'm not expecting you guys to know this yet. Just wanted to get it in your brain, give you a little sneak peek. Guess what? We do still have 7 minutes. I'm giving you an exit ticket. Oh, I'm sorry. Sorry. Y'all, hey, y'all didn't have an exit ticket the last 2 days. We'll live.
We can't go over.
Day 11.
No.
Exit ticket.
Alright, that does it. Biscuits.
Oh man. Okay, so for your exit ticket, I need you to solve the quadratic equation, and I'm not going to write the directions out. I'm going to give you the problem first so that you're not sitting here waiting for me. Let me find what I want to use. We'll have time. I'm going to give you an easy one.
Just one?
Just one today.
Why not 2?
What, you want to?
Stop.
X squared
Some of us are not overachievers.
plus
I'm not.
8x minus 9 equals 0.
Solve the cube.
Solve the quadratic equation for all values of x. And you can solve by factoring, or you could use the quadratic formula if you want. Up to you.
We know what Jeremiah's gonna do.
See, when I was in high school, I hated factoring because it just did not make sense in my brain for whatever reason. It like wouldn't click. So the quadratic formula was my favorite because I knew as long as I just put my numbers in the right spot, I would always get the right answer. With the factoring, I felt like I was always second guessing myself.
Yeah, it's the same with me.
Really? That's
It
funny.
really is.
The sass star? Oh my goodness.
He's my tutor, I can sassy.
Okay.
We're just factoring for X, right?
Yep, you're just, well, you're factoring, but then you're solving for
I
X.
don't know my, how to talk. I
You're good. You're good. All right, I'm going to end that recording. I forgot I was still recording. Y'all are free to go once you finish.